Okay, hello there. We're going to look at induction, division. So if you're looking at your textbooks, we're on page, 1B. Chapter 1, page 12. Thanks, Eth. Hope everyone was okay with their online stuff. It was okay. Oops. Yeah, so here we go. Use the principle of mathematical induction to prove that n to the 5 take n, woohoo, is divisible by 5. So I don't know if you remember the theory for this. We've got our steps. Anyone remember what's first step? P1. Positive. So we look at P1 and we've got 1 to the 5 minus 1, which becomes 0, and this is divisible by 5. Therefore, P1 is true. So I'm going to do my colour coding. We'll go the purple, the green, I said right. And so, therefore, P1 is true. So I'm putting the stuff in green. It's a must-have, right? You've got to have that in there. To prove, we're going to assume PK is true, right? And do we remember what we have to do with that one? What? I always forget. I always keep the K, the N's instead of K. So we say, right, K to the 5, oops, minus K equals, right, 5A, and we'll go back to the green because we have to say, yes, A is any integer there, right? Are we happy so far? So again, no real mathematics being done yet. To prove PK plus 1 is true. Oh, why did we choose this one? So therefore, we're going to go K. Ooh. Yes, hit the wrong one. Just stop for a moment. What we need to do here, I wasn't listening to you. What's our plan of attack here? Yes, but what are we trying to do? Right, so somewhere along here we have to fiddle with this, exactly. So we want to try and pull out 5 as a common factor, and somewhere in there we want to, right, and not want to, we have to use PK. Right? So your choices for this are you're either going to be subbing in K to the 5 equals 5A plus K, or you're going to be replacing K with K to the 5 take 5A, right? And the best bit is going to be, yes, expand. And we get a little bit happy after we go, oh my God, it's K plus 1 to the 5. We get a little bit happy because what can we use? Pascal! Right? Say it with enthusiasm, people. Enthusiasm. Pascal! Right? So Pascal requires a colour change. So 1, 1, 1, 2, 1, 1, 3, 3, 1. Oops. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. Right? So, what does that mean? That means I'm going to have to go down here now. So, K plus 1, you've probably already written this. Okay, so this now becomes 1 K to the 5 plus 5 K to the 4 times 1, but that's just 1, plus 10 K to the 3 times technically 1 squared. Remember the powers have to add up. I'm not going to write the ones anymore because we know 1 squared is just 1. Moses and Will. I told you, as soon as I take the roll, they'll come along. 10k squared plus 5k plus 1. And if you had been a bit slack and not put your brackets, right, we would have had minus k plus 1 instead of minus k take 1. We happy with that? Right? So what can we do? Well, the 1s are going to cancel. I'll just stop here because what you're going to do is now try and use, stop it. You're going to try and use that and see, does that allow you to pull out a common factor of 5? I mean, we're looking pretty sweet here. 5, 5, 5, 5. This one and this one are causing an issue, but they're involved up here. So let's see what happens. Beautiful. They're saying, yes, they got it. Now, Kunal was saying too, you've either got the option, right, when you're looking at this, we've got that bit there that you can replace, or you can rearrange and replace. So if you notice, sometimes you've got the k to the 5 and you've got minus k there. So you can actually straight away sub that in as being 5a. If you just replaced k to the 5 with 5a plus k, well then the k and the k will cancel and you get the same answer regardless. Does that make sense? But what you need to make sure you've put there is using pk, right? Why did I put brackets there? Put that around the whole thing. At those conferences you go to and they talk about the mark scheme, they always say, it's like with your first principles. If you don't include the limits all the time, that just becomes a mark off overall, even though all your mathematics was really good. So make sure that that's there, right? The last bit that you'd have to say is therefore pk, plus 1 is true. And then, what do we say? Hang on, we're coming around. Who wants to say it? The statement. I think Dan remembers.
Isn't it when p of 1 is true? Oh, no, since p of 1 is true and p of k plus 1 is true, whenever p of k is true, then p of n is true for, is it n is always real? Or positive integer or something like that?
Well done. Lovely, by PMI, yep, using PMI, proof by mathematical induction. Well done. The statement's in your textbook if you want to go and have a look. Now, you know, have we got time for every single one? No, but if you're in the mood for it, go forth. Just a little bit of a side note, Mac is up to E already, right? He started a little bit before, which is great. But a thing to remember, when you've got the division by 6 to show that it's divisible by 6, sometimes it's beautiful and you can pull out that common factor of 6, right? But there is this sometimes, and I don't know if this is the one, although it is. Yep. So just remember that sometimes when you've got the 6, I haven't really seen it in any other division apart from 6. Not sure why that is, but anyway, probably there's a reason. Is that what will happen is you'll be able to pull out 3 as a common factor quite easily, but you wouldn't be able to pull out 6. And you go, what have I done wrong? So instead of spending ages and ages trying to find an error that you pulled out 6, what you need to do is go, yes, I'm happy that I pulled out 3 as a common factor. And then look at what's in your bracket here, and can you prove that what's in the bracket is even, right? And if it is even, then an even number times 3 has to then be divisible by 6. And I think the one that we did last year from year 11, it was if you could prove you had a 3 times k plus 1, that had to be even. Why? Why is multiplying 2 consecutive numbers even? One's going to be odd and one's going to be even if they're consecutive numbers. Like pick consecutive numbers, 6 and 7. 6 times 7, it's got to be even. Pick another lot of consecutive numbers. What if you went odd first? Well, 3 times 4. Well, again, that's got to be even every single time. So consecutive numbers are always even, and an even number times 3 has to be. So that one would require you to make a little bit of a statement. Did it work, Mac? Uh-oh. All right. So maybe practice one more, and then we'll jump to E and make sure that we can do that. So having a crack at E. Everything up to this point is just routine, and when you're doing some of these questions for review or practicing, you know what, I'm quite happy if you sort of just write the PK plus 1 and you skip, although Will was saying, oh, I have a problem with the setting out, so then he should make sure that he does it. But you know, if I'm trying to save time, because yes, your time is precious, as is mine, you can skip some of the bits as long as you are fully understanding that what is required in a test / exam question. All right, so we've got this. We're going to have to expand, and by now we're really hoping Pascal is just a, you know, friendly little cousin that you have, and we can expand really quickly. So we've got k cubed plus 3. Oh, dear me. 3k squared plus 3k plus 1. Again, depending on when you're doing this, how tired you are, don't try and expand and multiply at the same time unless you're really, really confident. Right, you're just asking for trouble. All it takes is you forget to times the 1 by 3, or you just have 3k instead of, it ends up being 6k, and then you're stuffed. So just take a wee bit of time, and it also looks like you're doing a hell of a lot more work than you really are. That's always a winner chicken dinner. Actually, I'll just leave it as expanded. So nothing really impressive about that so far. Okay, we've just expanded, and I've left it all in expanded form because, once again, if we can find this, we can replace that with 6a. Okay, so I got myself a k cubed here. Have I got a 3k squared? Here a 3k squared, there a 3k squared, going well. And have I got a plus 2k? Yes, yes I do. So those are going to go, and I can now replace that with 6a. Okay, tidy up the rest of it. And what have we got? We've got a 3k squared. We've got a 9k, and you know, I'm doing this, put the little ticks, that's something I do when I've got lots of terms, so I don't miss one, I don't confuse a k for a k squared, and then 1, 4, 6. And we're quite happy here. Bobby's got me using PK. Thank you, Bobs. Right. And this is where we go, I mean, always double check, but when it's a 6, don't be surprised if you can pull out, as we said, 3 as a common factor, but not 6. Okay. And one of the things I'm going to do here is I'm going to go, well, I'll just tidy this bit up here, because what I can say is I've got 6a, and you don't have to do this, you've got various options, but I'm going to borrow 6k from here, and then I've got my 6, and so what I'm left with is 3k squared plus 3k. Do we agree that this line equals the top line? And again, as I said, you don't have to do that. You could have just pulled out 3 as a common factor from there, but you'll see why I've done that, because now with this, I can pull out my 6. So A plus K plus 1. Yeah. And then with this, what can I pull out? 3K. Right, 3K, and then I've got K plus 1. Right, and what we can now say is that this has to be even, since consecutive, numbers multiplied, right? Therefore, it's divisible by 6. Okay, and we would also have to say that this is also divisible by 6. Yeah, if you had not separated, you would have pulled out the 6 here and the 6 here, and you would have been left with 3K times K plus 3, right? 3K times K is 3K squared, and then you get your 9K, right? And I guess you could say the same thing there. You've got K plus 3. So you've got, think about it again. If you've got, if K was, shouldn't use 3, should I? If K was 1 and you add 3, then we get 4. It has to be an even number. If it was 7 and then you add 3, you get an even number. So again, you'd write a little comment if you did it that way. So there's not just one way, whichever way you want to go, but you must write just a little statement saying why that is even, hence divisible by 6. Yes? Da 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 da. Finished. So do not worry about the notation because that won't be you, but it's nothing too dodgy either. So we're basically saying I would start with 1, and this means the sum of. So when I is 1, we get 2. And then we're adding when I is 2 becomes 2 squared. When I is 3, 2 cubed. Remember this? And then it goes all the way up to when I is n. So to the 2n, and we're saying that this is equal to 2 to the n plus 1 take 2. So if there was a question for a summie, it would be written in the yellow, not the stuff at the top. But hopefully we know. All right, so crack on, see if you can remember some of this, and I'll be right behind you. Okay, so am I needing to do this one or did we get it done? Need me to do it? Right, so if you've done it, carry on to the next one. So what we've done here, I'm assuming you did P1, it worked. If it didn't, hopefully someone's going to tell me right now and go, this one can't be proved. We assume PK and we want to prove PK plus 1. Remember, one of the tips is always include. I like to include my K plus 1 there because now, sorry, G, I should write that a little bit bigger. Sorry, mate. I can see that that is in fact PK, right? So now I can replace that and I can say, right, this whole thing here is 2 to the K plus 1 minus 2 using PK, but then I've still got my plus 2 to the K plus 1 there, right? What am I trying to get towards? I've got my eye on the prize over here. So one of the things that I notice is that this minus 2 is just sort of sitting out all on its own. So one of the things I will do to help myself is I will plonk this minus 2 out to the right as well. So I'm left with 2 to the K plus 1 plus 2 to the K plus 1. I go, oh my goodness, when I've got 2 to the K plus 1 plus another 2 to the k plus 1. Iman, how many 2 to the k plus 1s have I got? 2. So I'm going to write that. I've got 2 lots of 2 to the k plus 1 minus 2. Remember, if you can't see it at this point, I mean, I hope you all can, but if you can't, you're looking at what you've got here. I'm doing indices with my year 9s. I might leave this on the board for them, right? When I've got, that's 2 to the 1 times 2 to the k plus 1. What is that? Huzzah! Therefore, or equals right hand side, therefore pk plus 1 is true. Statement. Ish. Insert statement here. Do you remember this?